When our own human computer, Ms. Shakuntala Devi, has said that without mathematics, there is nothing we can do. Everything here around us is either numbers or mathematics, and we could not disagree to that. And if you also agree by the same, and if you also abide by the same, you have come to the right place. So hello and welcome. This is Himanshi Kaushik, your host of the day, and I would like to welcome you all in today's webinar on exploring Vedic mathematics to do quick calculations. And I hope that you all are doing fine, safe, sound, and happy at wherever you're taking this webinar from. So before we move on and learn a lot more about mathematics today through our session, we have our expert here with us. So I shall introduce you to our expert. We have Dr. Geeta Arora ma'am, Professor, Department of Mathematics, School of Chemical Engineering and Physical Sciences, lovely professional university here with us. She has earned her PhD degree from IIT Roorkee and has over 11 years of teaching experience and published more than 50 research papers in national and international journals. She is a magnetic personality who has authored more than 10 book chapters in national and international publications. She has written books on quick calculation in mathematics and essential statistics also. Her interests are development of numerical methods and statistics. She has received many awards and conducted several workshops on MATLAB and Vedic mathematics. And she has been guiding many PhD and master students as well. So ma'am, it is a pleasure for us to be here, to be able to listen you in the webinar. And ma'am, looking forward for an amazing numeric session today.
Thank you, Manshi. Thank you so much. So maybe start with the session. Okay. So welcome to all. Here we are going to start with the session named as Exploring Mathematics. We are going to see what Vedic mathematics is and what we can do with help of it. Right. So here we are going to do some quick calculation in the time given to us. And let me introduce myself. Myself, Dr. Geeta, Professor in Mathematics Department, lovely professional university. And I'm sharing my mail address. In case you have any query and you want to know more about Vedic maths, you can contact me through mail. Right. Here is the book that I will recommend to you to go for. One is the Vedic Maths for All Ages by Varna Singhal. In this brief book, you can go through each and every minute discussion. And one is written by me with calculation in Vedic mathematics. Actually, I have not added the name mathematics because I have taken the tricks from Vedic maths and I have implemented directly that how we can go for making our mathematics easy, the calculation part easy, right? So you can purchase it from Notion Press and from Amazon Flipkart also in order to get insight into. Now, what Vedic mathematics can help you is, if I ask you that, can you multiply these two numbers? I think it's very large. No? So it's 7521645 into this series of 9. And just in 30 seconds without calculator. So obviously, if I know a trick, I can. But if I do not know a trick, it will be very hard to go for it. Right? So this you can learn if you are learning the trick to multiply these two. Right? Similarly, if we finding out the squares. So finding out the squares of some small number is feasible. But if we are going through the biggest number, obviously it will be challenging. And similarly for these numbers, right? And here you can see the time is being reduced and we are saying less than 3 seconds. So obviously it is possible, but if you don't do right now, so it doesn't matter, we can learn and implement it, right? Because we are thinking about that, how can we do without using a calculator, right? So without calculator, how it is possible? Yes, it is possible through the power of Vedic maths. We are going to learn what we can do. Vedic maths help you to speed up the calculation, working with the concept of geometries, divisibility, finding out the square roots, cube roots. And overall, if we say that it actually sharpen your mind, because when you're using your mind in doing number of things, a lot of calculations, obviously it will sharpen in your mind and will be, you can say, utilized in every field of the work you are doing, right? And if we talk about what or why we are learning Vedic maths, so it is 1700, yes, 1700% time faster than the normal maths. But yes, it needs practice because from our childhood, we have learned the normal type of calculation. We are not doing it in a different way. So once we are equipped with doing in a certain way, using the tricks, we can do it very quickly. And when we will do it, obviously it will eradicate, if you have any fear of mathematics, so it will eradicate that fear and you will be able to do it very quickly, because it actually make you intelligent, not in terms of mathematics, but yes, when you're using your mind, it will sharpen your mind and will improve your performance in school, colleges, and in any exam that you are taking, right? So let us explore what Vedic maths is. So Vedic maths is basically, you can say, an ancient technique that was given by our researchers that simplifies the calculation of multiplication, divisibility, squaring of number, finding out the cube root, and so on. And nowadays it has been researched more, and we can even use Vedic mathematics for doing the algebraic calculations and finding out the auxiliary fractions also, right? So this is all what I can explain what Vedic maths are, but we are going to explore this some more after the think fast activity. I can see there are some participants who have joined. So let us start with them. And what you have to do is you have to see that how much fast you can think, right? Because the main purpose of doing all these things is that I'm able to do all these things already in our head, right? So you need to do it. So I'm going to start with the first one. Try to do it in 1 minute. The time is also coming on the screen. I hope so you were able to see. It's not really okay. I think it's not working. This clock is not working here in the slideshow, but it is fine. 1 minute time has been given for calculating this. And as I have browsed, you might have seen the answer, right? But if I will ask you that, can you multiply these two numbers in just 1 minute? Obviously, it needs time, right? But if we are doing it, and if you have done, you can let me know. And if not, then we are going to see what is the trick, how we can find out the product of these two numbers, and you can see they are coming in thousands, right? So otherwise it is not possible if I do not need a trick. If we do not know a trick, it's really not possible. So let us discuss about that, how we have done. Here you can see we have 1004 multiplied by 1004. So what we are saying is the answer to be written in two parts. The first one is 1004, and I have seen that it is 1000 plus 4. So it is actually the increment. I'm not discussing the whole through, but just for a quick instance that how it can be done, I can see 4 plus 4 is 8. So here the 8 is coming from 4 plus 4. And we know 4 into 4 is 16. So it is coming from this. But it is not always that it can be done in this, because it depends on the base and the numbers to be multiplied, right? This is one such example that how we can do, right? Let's start with the next one. The clock is working, right? So I'm giving you 1 minute. Try to do it. And if you have done, you can let us know if you are getting the answer. That is 23414 divided by 5. So how it can be done? Either I have started doing the normal division, right? But this normal division takes time. I think the stop again, the clock again stops, right? It doesn't matter. You can take your time. And if you are doing by the normal trick that I am taking 5, means I'm dividing this number by 5, then the answer will come as this, but it will take time, right? So what the trick we can use it that whenever there is a number, here it is 23414, and I want to divide it by 5. So instead of dividing by 5, what I can say, it can be written as the number into, now 5 means I can say 10 by 2. 5 means 10 by 2, right? So if I will multiply this number by 2 and take a decimal from the end, means I'm dividing by 10. Whenever I'm dividing a number by 10, a decimal comes from the end if there is no 0, right? So if I will multiply, it will go to 46828, and putting a decimal because I am dividing by 10, give me the same answer, 4682.8. Right? So this is how we can use some simple tricks to make our work easy. Right? Let's start with the next one. Here it is. You have to multiply 21234 into 11, and again I have given the time of 1 minute. Right, so let's see how much fast you can do. And whenever we are doing the normal mathematics, you can think about the trick that is it the normal multiplication that will work, or I can go for something special to be done, right? So if we are looking for what special trick is there, so this is what the formula you can devise, and we are doing nothing special. It is just our researchers, the scientists, the mathematician have looked into the pattern that is repeating, and they are writing out this as a Vedic mathematical trick, right? Because earlier all the things has been given by the acharyas. Now we are just trying to find out that how it can be done in a normal mathematics form, right? So hope so you might have obtained the answer. So let us also discuss that how to obtain the answer by the normal way and how to get it by the Vedic maths. So let me show you the answer is coming as 233,574. So if you have done, obviously it's a good thing. And if you have done normally, then you can still make it in a different way. The number is 21234. Normally, when we have learned mathematics, it has been given to multiply like this. And we are saying that the first row will be 21234, put across here, and this 21234, and then we are adding, right? This is what we have learned at a normal way, and the number of rows need to be written. But now what we can say, if I need to multiply any of the number by 11, write down the last number as such. So 4 I have written as such. Then what we are doing is I'm adding the two numbers from the end in a continuous way till I will reach the starting, the initial value. So 4 plus 3, 7, 2 plus 3, 5, 1 plus 2, 3, 2 plus 1, 3, and this number again to be written as the digit. So the first digit and the last digit need to be written as such, and then we are going to start adding two digits continuously from the end till we have reached the front digit, right? So this is just an instance that how we are quickly doing the calculation by 11. And if you have done it in this way, this also can be done in less than 1 minute, right? Because it's very easy, nothing is to be done. But this we have practiced from our many years since we have started learning. And if I will practice this, so you can do it just in, I can say, very less time as compared to the normal, right? So it all comes by practice that we can do. Let's start for the next one. Here's a simple one, 85 into 99. Start doing and see that, are you able to do it in less than 1 minute? And if not, then can it be done in some other way that the time, whatever we are taking, should be reduced? Because now we have having a competitive time that we all need less time to do more and more calculation to verify our answers. So whenever there is a need to do quick calculation, rather than going for the normal one, we need something different, right? So that is what we are looking at Vedic maths. So you have done in the normal one also, you might have done if you know the table of 9, right? Or there is one more trick that without Vedic maths trick also I can use. So let the time be pass and I will share it with you. It's 6, 5, 4, 3, 2, and 1. So you might have done, right? I'm not asking, but if it is so, check your answer. Is it 8415? And if it is yes, then yes, thumbs up for you. You have done. Now, what are the tricks that we can use? Let me start doing in the normal way. If I have to do, I will do like this. I need the multiplication table of 9, but I think it's boring. We need to write down each time 9 into 5 and so on. So what the new trick we can use, either I can use as a trick, means it is a normal mathematics trick that 99 can be taken as 100 minus 1. And instead of multiplying by 99, I can say it is 8500 minus of 85, right? That's you might have already done. In some of the classes, we have seen that whenever the number is near about 100, then we can use this trick either plus or minus, and we can easily get the answer. It's easy as compared to this one, right? Now, what more trick I can let you know is that in Vedic mathematics, we are saying the series multiplication by 9, that if here we are having 2-digit number and I'm multiplying by series of 9 with 2 digits, means the number of 9s and the number of digits in the number is same. Then I have to write down the answer is number minus 1 into, we are saying in Vedic maths we have complement of number. And one complement of number is it's different from the base. right? Here and I'm not exploring much, but when you will read out the books, you will see that it's very easy that the number is here. I'm multiplying by a series of 9 and the number of digits are same. So 85 1 minus 1 directly will give me the first two digits, 84. And now what is the complement of number? So actually it is the difference of number from its base. Now what a base is? Base in Vedic maths are 10, 100, 1000. And whenever the number are near about these, we are calling these as bases, right? So here complement of the number means you have to subtract 85 from 100, right? Now here also you can do the normal subtraction that you might have done or practiced from a long ago. But here again, Vedic mathematics plays a role because here we are saying that there is no need to take a carry or a borrow, right? Normally, if I have to do what I can say, I will borrow 1 from here. So it becomes 10, 10 minus 5 is 5. Here it becomes 9, 9 minus 8 is 1. This is the normal way, right? But if I am finding out the difference of 85 from 100 from any of the digits, we are finding out the difference. So it's all says that whenever the number is small, then actually we are also doing the same thing, but we are saying that there is no need to borrow it. We are saying all from 9 and the last from 10. Is if I have a series of 1 and followed by 0 and I'm subtracting something from it, I have to say here I will subtract from 10 and all others will be reduced to 9. Right? So this comes by practice, but this is what we are using for finding out the complement. Right? Now this is the last one. I think you all can do it in much less time as I have given 1 minute. Right? So it's 34 plus 56 plus 22 plus 18 plus 10. Again, you can use a trick and do it very quickly. And you can think for if you, because it's normal addition. There's no need to do actually, but you need to think that is there any trick that I can implement here? And when you are doing the calculation, then obviously you know what the trick can be used, right? So what the trick we can use? Yes, we can use the trick of finding out the sum of the numbers that makes 10 in the last. So here I can say 34 plus 56. And then I can say 22 plus 18 can be added and 10 can be added again, right? And another way to look at the problem is I can say this is 30 plus 50 and 4 plus 6 is 10. Instead of 22 plus 18, I will do in my mind that it is 20 plus 10, 30 and 8 plus 2 again 10 and then 10 as such. Right, so this is a trick that I can use, that instead of looking at as 34 plus 56, I mean, if you will ask a kid to do 34 plus 56, obviously they will start writing out 4 plus 6, 10, 0 and 1 carry. Right, here we are saying do as much less carry and borrow as possible. So I can say 30 plus 50, 80 and 4 plus 6 means again 80 plus 10, 90, 90 plus 20 and 30 and plus 10 plus 10. So total is there really a need to do a quick calculation because it is a need of today, right? So whenever there is a need to do the quick calculation, we have to go for some of the tricks that can be implemented in our work to do fast as compared to others, right? So let us now start with that. What is Vedic mathematics and what do we learn with the help of Vedic mathematics? So Vedic mathematics helps you in doing addition, subtraction, in learning multiplication, finding out the divisions, in finding out the digital root. It's actually very good concept that I like the most because it helps the students to answer the MCQs very quickly. Or I can say if you have solved something and you want to verify your answer, then rather than going through the whole procedure, the concept of digital root can be explored, right? Then we have squares, cubes, square roots, cube roots, all can be dealt with Vedic maths. Now here if I talk about the ancient history and those who have given the Vedic maths, they have given us these 16 sutras And based upon these 16 sutra and some sub-sutra, the 13 sub-sutra, actually we have devised the form of Vedic maths that we are learning. Means we are not saying all these, actually I do not know the names exactly, but yes, when it is coming to numbers, then we can understand and we can do with help of all these things, right? So today what trick I'm going to share with you is the simplest one, finding square of a 2-digit number that ends in 5, right? So here we have, and rather than showing you the slide, first I will elaborate you with the help of pen, and then we are going to see what the rules are, right? Because orally it can be taught very easily. So if I talk about how to find out square of 25, so I think all of you know, because if we are doing calculation, we know the answer is 625, right? But have you ever thought of that how we are getting it out? What is the quick way? Means this we have learned actually. But if you will ask a small standard kid, they have to do the same thing as 25 into 25 and getting the whole steps and adding them, and then we are getting 625. We might have learned, right? But here we are going to see what is a trick to do the same. So what I can say, the quick trick is that if a number ends in 5, so the square of the number always ends in 25, right? You can observe a number of squares are there, and you can observe that whenever a number is ending in 5, then the answer of its square always ends in 25. So here if I have 25 squares, obviously 25 is coming by default. It will come. Now what about the first part? First part is coming as number into its successor. This is the simple rule. That if I'm finding out square of 25, the first digit is 2, the last digit is 5. So the last 2 digits of the answer will be 25, and the first digit of the answer depends upon this first digit. So if it is 2 multiplied by its successor, it means 2 into 3. Successor means the next number. So 2 into 3 gives me 6 and followed by 25. So the answer becomes 625, right? So it's very easy. And the same thing is written over here that I have to take the last part. The first part means you have to split the number in 2 parts, and then you have to do the calculation accordingly. 5 square 25 comes at the end, and the first digit is 2. So I have to write down the answer as 2 multiplied by its successor, 2 plus 1. Right? So 2 into 3 is 6, 25. Let's do some more. Here's another example, 65. So hope so you can do it very quickly without waiting for me. What is 65 square? So I have to say 6 into its successor followed by what it is? Yes, it is 25. So there is nothing to do the normal calculation. 6 into 7 gives me 42 and 25 as such. So the answer is 4225. Very easy. I feel so. I hope so. You also feel like that it's really very easy when we are finding out 65 square or any number that ends with 5 and we are finding out its square. Right? So here you can see we are getting 6 into 7, 42, the first part. And since it ends in 5 and the square of 5 is 25, we are getting 4225. Right? It's easy. Right? Let's do the next one. And here we have taken a 3-digit number. Now a 3-digit number means 125 I have taken for example. So again, is the rule going to change? No, it will remain same. And now what we are saying, 12 into its successor, that is 12 into 13 and 14 by 5. So 5 square is 25, right? So again, here, again, I have to multiply. There is a trick, but I'm not sharing because it takes time. But you can do, and when you will do 12 into 13, it comes 156, and then it followed by 25. So the answer is 15625. Right? So easy.
I'm very sorry to interrupt. Ma'am, Renu Bala, the student says that kindly use some different color pen because red color is not visible on black.
Manshi was saying something. I think the speaker is low. Let me increase the volume.
Okay, am I audible, ma'am?
Yeah.
Yeah,
it's fine.
Yeah, ma'am, the student says kindly use some different ink, different color pen because this red color is not.
Any light color? You will be okay.
I take yellow. Blue is also fine. Blue is also visible.
So here we have some examples that you can try by your own. And here we are saying 45 square, 85 square, 95 square. So I think that if I go for 95 square, it will be very easy and you can give the answer just in quick, I think in seconds, right? 9 into 10, 90, and 5 square is 25. So the answer is 9025. Really easy, right? 105 square, it is 110 followed by 25. So the answer 11025. So quickly we can write down the square of a 3-digit number, right? Then 125 we already did. 195 square. So it is 19 into 20. I think we can do it easily and orally. So it is 38025. Right? You can verify it. I think I'm correct, but still you can verify. 19 into 20 gives you 380 and followed by 25. Right? So this is how we can find out square of a number in quick way. Right? Now let's start with the next thing. Here we have product of 2-digit number with sum of last digit as 10. Now still now we have seen that if I have, where it will work, 65 square. So I was writing out it as 6 into 7 followed by 25, right? This is what we have learned for number square that ends in 5. Now the same trick we are going to use here when it is product of 2-digit number to be obtained and the sum of last digit is going to be 10. So here are some examples that 53 into 57. Now when we are saying 53 into 57, so you can say 5 is same in both of the numbers. It starts from 5 and the last digits 3 and 7 are being framed such as 3 plus 7 is 10. Right? So it is just like this. Here we are saying, we can say 65 square means 65 into 65 means the starting number is same, right? And it ends in a number whose sum is 10. So this thing can be generalized for any of the number to be multiplied that starts with the same digit and the ending digits are giving me the sum as 10. So 53 into 57, yes, I can do the rule. 74 into 76, yes, 7 is common, 4 and 6 gives me the sum as 10, right? Similarly, 82 into 88, so it is 8 common and 2 plus 8 is 10, right? So we can do it. So let's start learning the rule. Again, it can be told orally, but here I have written for the clarity that multiply the number by its next number. And instead of writing out 25, as we did in the last number with 5, we are saying multiply the last 2 digits. For example, if I have to find out 48 into 42, so 4 is same here. So what I will do, 4 into its successor will give me 4 into 5, 20. And since here 8 and 2 are the digits whose sum is 10. So I will say 8 into 2. That gives me 16 and I have to just note down together to get the final answer, right? So you can synchronize by looking at 45 into 45. There we also did the same thing. 4 was common. So 4 into 5 we did 20. 4 into 5, 20. And there since it is 5 and 5, we are saying 5 square is 25. Now here the changes, the numbers are changed at the end place, at the unit place, and we are saying now those numbers are appearing whose sum is 10, right? So we are getting 4 into 5 and followed by 8 into 2. So the answer is 2016, right? So it's very easy. Similarly, 83 into 87. So here again, 8 is same. So 8 into its successor, that is 8 into 9 gives me 72. And 3 into 7 gives me 21. So put them together and you will get the answer. It's easy enough. Whenever you are doing some of the multiplication and you got this thing, so might be your competitor might not be able to do if they do not know the trick, but you can do it much faster, right? Because you know the tricks now. So here we have some examples. Let me browse through and some we can pick up. Let us start from the C part. Right, you can say 93 into 97. So what it is, 93 into 97? I think we can do it totally. 9 into 10. So it will be 90. And 3 into 7, 21. Right, the next one, 56 into 54. So I'm not going too fast. If you have not understood, then put a message and I will come to know that if there is some problem that you are getting through. Right? So what is 56 into 54? 56 into 54? Yes, I'm waiting for your response. Right. It is 5 into 6, 30. And 6 into 4, 24. So we have the answer. What about the next one? 115 into 115. Means now we are having 11 into 12 followed by 25. Right? Because here we are having last digit as 5. So 5 5s are 25. And 11 into 12, now you can use the trick. And I have also written the whole thing that how we can multiply a number by 11. So when it is 12, last digit as such, 2 plus 1, 3, and 1 as such. So it's giving me 12 into 11 as 132. Right? So 132 followed by 25, 132, 25. Fine. So this is how we are doing the product of two numbers that ends in 5 and the starting digits are same. Right? So this is how we are doing. Is it fine? So let us go for some next things. Let's explore what other things I have added in the PPT. Okay, here comes the brain gym. I know we all are interested in doing other things other than maths because Vedic maths is actually a type of trick mathematics we are using. And in between, we need some break because when you're doing calculations, sometimes it got strict, right? So here we have a puzzle type of thing, and I'm actually interested in all these things. In my book also, there are a number of puzzles I have added. And here in the university also, we are taking the classes along with some amusement to add in order to work out the brain. So here we are. Can you connect these 9 dots with only 4 straight line segments without losing contact with the paper? And how I'm expecting is, I know that in childhood, you might have done some of the puzzles to draw something like this. So I have not taken out the contact of my pen from the paper and I'm drawing continuously, right? Something like this. Something like this. So you have to try, there are 9 dots being given. You have to join them only using 4 lines, and 4 lines means 4 lines. So here I can say 1 line, 2 lines, 3 lines, 4 lines are here. Similarly, you need to draw some lines, and I'm saying you have to join using 4 lines so that the touch of the pen and paper should not be violent. So try it out, and if you can't show me, but yes, you can try. Okay, one of you is saying how to do with 3 digits for measuring. Is it you are asking for the trick we have done? We are looking for how we have done with the product. So it is just the same thing. Let me write it down that what we have discussed. Okay, you understood. That's fine. Let's try for this. How it can be done, you can't show me, but I'm giving you some time because I know when I have started or whenever I used to ask from the students, it takes time, right? Normally we can do it with a 5 or 6 lines. So just try it out, and if you can do, obviously that's great, and we can move on to the next trick of Vedic maths, right? Because learning maths is obviously challenging, and for 1 hour, if you have to study continuously, it's really very hard, right? And I appreciate to you that you are attending and you are learning the things. write out. If anyone has done, give me a message so that we can know that you are done with. Okay, one of you are saying it's done. That's great if you have really done. But normally in my classes, what happens is students are saying that they have done, but they have taken more than 4 lines, right? The pattern you are getting, if you can explain it in words, you can't show me, but yes, you can write it on the which type of pattern. As you can say that this is my hut type of structure, this is a square, this is something as a star. So just write it down, that which type of pattern you are getting.
Ma'am, we can allow them to talk if you want and if the student wants.
If you can allow, please allow them.
Yeah, okay.
So that I can find out that anyone who can done.
Yeah, okay. So Sukanya has done, right? So I'm allowing you, Sukanya, to talk to ma'am and to give the answers just in a moment. Yeah, Sukanya, you're on the page now. Kindly please, yeah.
Yes, ma'am. First, I have drawn a diagonal line joining the first and the middle and the last. Then I have joined the first row. Of 1, 2, 3, the first row. Then I joined the sixth and the eighth line, eighth dot, joining a line, and then I have joined the first column.
I'm actually not able to understand if it is, but it's fine that if you have tried starting from the diagonal, yes, it is a possibility that you have done it, right? And let me show you because I think it's enough time for a quiz to be done. So let's start with, this is the pattern of 9 dots, and how we can solve it is, this is the first line, this is the second, the third, and the fourth. And normally, let me show you that when we are doing what we are actually doing is here, if we have the 9 dots, we usually starts like this, that 1, 2, 3, 4, and then this will remains. If I have started from the diagonal, some I have seen doing like this, 1, 2, but if I will try to connect it here and then somehow going through, so either it will overlap, it's fine, we can overlap, but we have to cover the 9 dots, right? So the thinking is that whenever we are doing something, we have to do out of the box. We have to think out of the box because we have to keep ourselves different from others, right? So you can start from any, and here, if it is being started here, it's fine. Normally, I used to start from here, the diagonal 1, not covering, I'm not very much good in this, but it's 2. If I will turn from here, it will not join. So I have to come out of the area, right? Then it is the third line, and then I will go back, and this is how I can cover all 9 dots, right? And you can see the touch of the pen is not going up, right? So we have to be constantly touch with the things, right? And this is actually a motivation that I like the most, that whenever we are doing something, we have not to lose our contact, and we have to give our best efforts that I can, right? So let's start with the next thing. Now here we are exploring the same thing that we did, the multiplication by 11. You might have understood, but here we have the rules also being mentioned, that what is the rule or the sutra. So here we have only the last 2 digits. We are pronouncing it like that we are using only the last 2 digits, right? So here we have to understand in our details. I can say the first step is make a 0 sandwich. And we like the sandwich a lot, right? In mathematics also, we are doing some sandwich type of thing. So we are making a 0 sandwich, add the last 2 digits, and then if carry occur, take it to the next step. Right? So let's see how we are doing it. Here we have an example, 123 into 11. So the first step is make a 0 sandwich. So we can see here coming 2 dots on both sides, right? Then we have to write down, actually when I have told you, I was saying directly that put the last digits as such, But if we are going through the rules and learning step by step, so we are saying first we have created a zero sandwich, then we are adding the last two digits. That's why the rule says only last two digits. But what we are doing is we are adding the last two digits from right, forming a chain. So it is actually 3 plus 0. That gives you 3. Then 3 plus 2 gives you 5. 2 plus 1 gives you 3. And again, 1 plus 0 gives you 1. Right? So when we did the practice, we know that the last digit and the first digits are going to be unchanged because we are adding it to 0. But when you are teaching it to a kid, you can say that add the last two digits and a continuous manner. So we are taking 0 plus 3 always will be 3. 0 plus 1, the first digit always will become 1. Right here, we have some more examples. 1, 2 into 11 will give me 2, 2 plus 1, 3, 4 plus 1, 5, and 4 as such. So the answer is 4, 5, 3, 2. Quickly go the next one, 5, 3, 1, 2. Now do it and quickly give me the answer. Let me see how many you can do quickly, very fast. And it's all to be written from the end. So 5, 3, 1, 2 into 11. Yes, one of you have written. Let's find out the answer. Is it correct? So it is 2, 2 plus 1, 3, 3 plus 1, 4, 3 plus 5, 8, and the final answer is 5, 5, 8, 4, 3, 2. Right? So you are correct. You got the answers. Right? So here we have some more examples that you can practice. And obviously you can easily go through it and find out the correct answer. Right? So I'm just browsing it through and let's move on. What carry? Now what the change is here that till now when we have done very simple examples when there were no carry, right? But now we are going to start with when carry can occur. Now carry can occur means, let us see. Now I'm not doing it by the sandwich type of thing. Let's do it directly. Now it is 3, 5, 6, 2, 1. I need to multiply by 11. So last digit as such, or I can say 0 plus 1 is 1. 2 plus 1, 3, 6 plus 2, 8. Now it is 6 plus 5. Till now we have not done this type of thing, right? So now we are saying 5 plus 6, it is 11. So 1 and 1 carry. 5 plus 3, 8, 8 plus 1, 9, and then 3 as such. So that involves a carry. So we have to take it to the next step. So 1 plus 2, 3, 6 plus 2, 8, 5 plus 6, 11. So I have written 1 and 1 carry. So 3 plus 5, 8. Thus, I have added the carry 9 and the last digit again as such. Right? So this is how we are doing. So try the next one. 5, 9, 1, 2, 3. It again involves a carry. So try it out if you can.
Okay, I am getting all the answers in here. So I've got answer from Priyobroto. And I think there are different answers that I'm getting.
Okay, so here we are getting a different answer. Here some is saying 660353 and some is saying 59. So here we got the answers which are different, but I think it's still simple. So let us quickly go through it, how we are getting. So it is again the same thing we need to do. It's 5, 9, 1, 2, 3. So last digit as such, 3 plus 2, 5, 2 plus 1, 3, 9 plus 1, 10. So that is 9 plus 10, 20, so 0 and 1 carry here. 9 plus 5, 14 plus 1, 15. So 5 and 1 carry here this time. Right? So you have to see where the carry is appearing. And when it is actually 0, because we are making a sandwich. So 1 plus 5 comes as 6. So the answer is 6, 5, 0, 3, 5, 3. Right? So I think you all can do it. It's just that we have to take care of where the carry exists. Right? So a number of examples are there. And now I think it's enough to go for the Vedic maths. Again, I have a quick quiz for you. And here I'm again giving you some lines because mathematics is all about numbers and lines, right? So here you have to divide this crescent. I hope so. All of you know that this shape is crescent. You have to divide it into 6 parts by just drawing 2 straight lines. So try it out. We have 2 straight lines that we can use, and we need to divide it into 6 parts. So try it out. Draw it and look for the things that how you can draw and break it into 2 parts. So it's 6 parts. The total 6 parts are required. And I'm showing you the answer also because we have to wind up the session by giving you some more information. So here we have, and when you will do, it will not give you the answer very quickly, right? See here, this is the 1 line, this is the 2nd line, and I have noted down that what are the 6 parts. Because generally what happened that whenever I have taken this for the class, how the students are doing this, for the crescent shape, normally if I go for the 2 lines, I can draw like this, and normally it goes divided either into 3 parts, or if I try to divide like 1 here or breaking it here, it is 3 parts, means you have to try a lot. And if it is breaking it between, as here you can see, I can draw something like this and this, then we have to count 1, 2, 3, 4, how many parts are there? And it needs very, you can say, concise type of understanding that how we can do so that we can divide it into total 6 parts. And so I'm not giving you much time, but yes, if you will ask to somebody, you can see that it needs too much time to understand and get it to the answer, right? So quickly, I'm taking to the next thing, that is multiplication by 12, and we will wind up the session. Here we have just a simple modification for multiplication by 12 that says that instead of 11, when I'm multiplying by 12, so what needs to be done? So you can observe it. Whenever we are multiplying, let us take, I have to multiply 20 by 12, right? When we have done with 11, we added it twice like this. It's the same thing as what we followed in our trick. Here when we are saying, here 2 into 3 is 6, 2 into 2, 4, means once I'm multiplying by 2, putting across here and then multiplying by 1 and then noting down the answer. This is what I'm getting. Now what we can do in order to get in a 1 step. So here we have the rule of Vedic maths that sum of last digit, the last digit, and twice the second last digit. And this is the rule we have. So quickly let us browse so that you can explore by your own. The rule starts as such by making a 0 sandwich. Then we are saying add the last digit. This time we are saying add the last digit and twice of the second last. And if carry exists, then take it to the next step, right? Let's do it by example, 124 into 12. So putting zeros, we have made a sandwich. Then what we are doing is 0 plus 4 into 2. So 4 into 2 gives me 8. Then last 2 we have done. Now it's 2 and 4. So it is with which I have to multiply? 2. 2 into 2 plus 4 gives me 8. Now it is the next 1. So 1 into 2 and plus 2 is 4. And then 0 into 2 plus 1 gives me 1. Right? So this is the quick trick by multiplication by 12. How we did it by 11 and what to be done when we are requiring by 12. And actually it can be implemented by any of the number in the same way. That's why I want to just show that how we can do by 12, because if you have a knowledge of this, you can extend it with the other numbers as well. That how to multiply by 12, 13, 14. Obviously, it will be hard for the first time, but when we practice enough, we will be able to do very quickly, right? So let's see 2 more examples. 532 into 12. Now 2 into 2 plus 0 gives me 4. 3 into 2, 6 plus 2, 8. 5 into 2, 10. 10 plus 3, 13. 3 now comes 1 carry. And now we are having 0 into 2 plus 5 and plus 1 carry was also there. right? So total answer is 6384, right? Now try by yourself if you are having the next number, try it out. 5162 into 12. Now let me see who can answer me. I 162 into 12. So I need to put zeros first, right? So we are having zeros first. Then 2 into 2 plus 0 gives me 4. Then starts from 6. 6 into 2, 12 plus 2, 14. Now comes 1 carry also. So you can note down 1 carry is also there, right? Separately you can put it as 1 carry. Now 1 into 2 plus 6. So comes 8 plus 1 carry was also there. So total 9. Now again 5 into 2, 10. 10 plus 1, 11. Now again comes 1 carry. And then 0 into 2 plus 5 and plus 1 gives me 6. Right? So this is how we are doing multiplication by 12. Right? So I think we can stop here. Yes, Himanshu? Right? So we have learned some Vedic math trick of squaring, multiplication by 11 and multiplication by 12. There are some more things, but I think time is not enough. We can plan some session to do all these things and learn a lot from it. Right?
Thank you, ma'am. First of all, for giving this live visual presentation. I mean, it is like very practical for all the students and attendees also, you know, to learn how to do the calculation rather than just all the presentation that already has the written material on it. So I hope that they've enjoyed. And Samriddhi says thank you, ma'am. Renubala says thank you, ma'am. So they are all thanking you, ma'am, for the presentation that you've given. And ma'am, okay, so Parmeshwari wants to ask for the PPT. Can she have the PPT? Can she has the PPT that you've presented? Ma'am, am I audible?
Yes. What is Parmeshwari saying?
She's saying that can like you send the PPT? Is there any way
Yes,
she can have it?
you can ask me, means I have shared my mail address. It's GEETA@gmail.com. So whoever wants to have either the PPT or the book I have, so you can write me and I will reply to you. Right? It can be done. Let me type here in the chat box. It's GEETA@gmail.com. Right? So it will be helpful.
I will be just posting the same ID for everyone in here. You have
the book name you are saying is Quick Calculation in Mathematics. So you can search for my name on Amazon and write down Quick Calculation, right? And you will be able to get it. And one more book is there. One is just having Vedic maths, and other I have added with the puzzles that I have just shared. It is Interactive Skills in Mathematics. I'm writing out Interactive Skills in Mathematics. So there are 2 books that is available. You can go for any book. The Vedic math tricks are near about same, but the changes in interactive skills, I have added some of the puzzles that we did some of the puzzles here. So that is a thing being added here. And in Vedic maths, there are some, but not much. Right?
Yeah.
So it depends upon you. You can choose. Otherwise, I can also share you the PPT. Whatever is being shared with you here, we can go for it. Right?
So to all the participants, you can just interact with ma'am on her personal email as well. You can ask your queries as well, and the PPT that all the students wanted, you can just write her and she will be replying to you. And we're waiting for other queries as well. If you have any other query related to the math that ma'am has shown to you, you can just directly post in Q&A box, or we can allow you to chat. Meanwhile, ma'am, we have a query from Smiley Sharma. So with your permission, can I take that up?
Yeah.
Okay. Ma'am, she says, ma'am, okay, this is kind of a question that she has written. 21234 multiplied by 11 can be followed when okay, so should I maybe write this in the chat box, ma'am? Because I think it's kind of a mathematics question.
I think I have opened it saying that 2, 2, 3, 4 into 11 performer can be followed when multiplying with 11 or with numbers having same digit like 11. No, I'm actually not getting the question, but yes, it is that suppose I have to multiply by 22 or 33. And first I will multiply by 11 and then I can multiply by 2 again, right? Otherwise, it will be hectic to go for the rules by 22. Yes, we can extend it. But the thing is, we can first follow easily with the multiplication by 11 and then multiply by 2, right?
So I hope, Smiley, that you've got the answer. And we're waiting for the questions. If you have any query that you have or anything that you want to ask from our expert, she's in here. She will be replying to you. And meanwhile, meanwhile they ask their queries, I would like to take up some admission process queries that we've had. So I just wanted to show them a little about the site and how they can take admission in the LPU University. So can I, ma'am?
Yeah, you can go for it.
Yeah. Okay, to all, just in a moment, to all the students who had queries regarding the admission process as to how you can take admission in your favorite course, right? There's one short resolution for that particular thing, and that is our website. And I hope that website is visible to you. That is lpu.in. lpu.in will be this website you can see in here. See, this is going to be our website in here. So you can simply just write this website in the browser that you have, and this will be the interface that will be showing in front of you. Now, these are all the happenings, or you can say highlights of our university that has either happened or that are presently happening, or they may happen in the near future, of course, or related to the university only. Now, since we're catering about admissions, we simply go to the admission in here and we see there are a whole lot of different segregated programs, right? You can see after 12th, after graduation, after postgrad, after 10th, diploma, etc. Now, let's say we're taking an example of after 12th undergraduate program. So we simply click on this after 12th regular undergraduate programs, and once we click on that, we have whole lot of disciplines that LPU has to provide to all the students. You can see, you name any discipline that that you have in your mind, and we have this on the website. So you can see engineering, management, law, history, psychology, biotechnology, botany. And since we were talking a lot about mathematics today and statistics today, so why not take an example of the same? So I'm going to be taking an example of mathematics and statistics. You simply click on that particular math or stats here, and the courses that are available under that particular domain, particular discipline is visible to you. Now, let's say, so basically we have two courses, BSc Honors Maths and BSc Honors Statistics in tie-up with IBM. So let's say we're going to take an example of BSc Maths Honors, and this will be the interface that is coming in front of me. Now, so these are actually all the options that you would be required to know details about your particular course, right? So program details, once you click on that, this will show you the eligibility criteria, whether you're eligible or not. You need to find it from the program details. And after that, highlight option would give you your placement, research, student achievement rankings of the university. The curriculum part does show you all the curriculum that is there under at particular particular course. For example, all the topics that you will be taught are already given beforehand here. Now is the fee structure. I would like to draw your attention to this. We have a fee structure and we have our scholarships as well. So this is our fee per semester, but this is not the usual fee that our students pay. Why? Because they get a lot of scholarships, and on what basis? These are those bases. So you need to just explore if you fall in what category of the scholarship, and then you'll be getting scholarship based on that, and you can get up to 28% scholarship on your program fee. Now we have the most important part is important date. Okay, the important date is 31st May 2023. So I'd ask you to kindly take admission, because it's not too far now. It's just 5-6 days now. And how you can apply, simply click on here. You are required to give some bare minimum requirements and click submit, and then you'll be given a dashboard, and then you can simply apply. Last but not the least are the numbers. If you have any other query related to admission process, admission query, you can just write these numbers down or take a screenshot of them. You can call us, and then we will be here. Our counselors will be here to provide their assistance to you and resolve all your queries. And I hope that I have given you basic information, basic idea as to how you can go to the site and how you can search for your particular course that you want to take admission in. And now, since we're not having any queries, I'd like to take permission from all the attendees and to ma'am also, from ma'am also, to wrap this webinar up. So ma'am, attendees, if you do not want to add anything, ma'am.
Thank you so much, Himanshi. It was nice session for you. Yes, you have presented all the things very well and organized it very well. Thank you so
Thank
much.
you so much, ma'am. Pleasure is mine to be able to hear you in the webinar, to get all the knowledge through the presentation today. And I hope that participants also must have enjoyed thoroughly, like I was enjoying. I was doing calculations on my paper as well. So, and participants are already thanking you. So with this, I'd like to thank all the participants as well for being here for so long now, for being so patient and valuable, and for giving your answers. So until next webinar, stay safe and stay healthy. And thank you so much for joining in. And okay, before I wrap this session up, we have other webinars also that are coming in. So you can just find all the webinars on our site, that is lpu.in. Go to Edu-Fair webinars page and you will be finding all the webinars. You can apply, they are all free. And in whichever webinar, in whichever topic you feel interested in, you can simply apply to that. And thank you so much again for joining in, and meet you soon in the next webinar.